So we have exponential equation and log equation. Now the very first property that helps us to solve exponential equation is, so if we have, let's say we have an exponential expression a to the power x equals to a to the power y. Can you tell me one common thing that we have in these two log expression? What is one common thing? The base is same, right? So here this is base, and our exponents are different. So if we have a two log expression equals to each other, and if their base is exactly same, then this tells that our exponent also has to be same. So we have a two different log exponential expression with exactly same base. Okay, if this is the case, then the exponent also has to be equals to each other. Okay, so this is the first property. Now let's use this property in our example. So here we have 2 to the power t equals to 128. Now, what kind of equation is this? Our variable is t, and t variable is in the exponent here. So this is our exponential equation. Okay, now to solve this equation, we rewrite this equation with the same base on both sides. So on the left side, what is our base? Base is 2. On the right side, what is our base? 128. Now, is there any way to rewrite 128 as a base of 2? Can we do that? We need a 2, okay? So we have 2 as a base here, and we have 128 on the right side. Now, we have to rewrite 128 as a 2 to the power what? Is there any way we could rewrite 128 as a 2 to the some number power?
Possibly do like what we did yesterday, put 128 on the side and see what can go into 128.
Now, yesterday we didn't solve an equation. So today we have an equation here. Okay, so we simplify. So in our last class we simplified the log expression. So here we are solving this exponential equation. Okay, now we might need to use those properties too. Now here we have 128. Now how can we rewrite 128 with a base 2? 2 to the power 7. Okay, so our 128 is, so we have 2 to the power t as it is, and 128 is 2 to the power 7. Now, we have exactly same base on both sides. Now, using this property, what is our t? Now, can you tell us what is our t equals to? It's 7. This is our answer. Okay, so t equals to 7 is the solution. So if you have an exponential equation, always try to rewrite with the same base on both sides. Okay, if you have an expression with the same base on both sides, then you can write exponents equals to each other and simplify from there. So this is the first way to simplify our exponential equation. Yeah, so our target is finding the value of t, and our t is 7. We are solving means we are finding the value of variable, and which is t.
So you're saying basically 2 times 7 or 7 times 2 doesn't matter?
No. So here we have 128. 128 is, so if you multiply 2 7 times, we get 128. Okay, so 128 is same as 2 to the power 7. Now we have a base 2 here. We have a base 2 here. So if we have a same base, then this exponent has to be equals to each other. So t is equals to 7, and that's what we need. So we are trying to find the value of t, and which is 7. Now, the next here, we have the next exponential equation. Okay, we have 10 to the power, so we have 10 to the power 2x minus 1 and 3 to the power x. What is base on the left side? It is 10. What is base on the right side? It is 3. Now, is it possible for us to have a same base on both sides? Can we rewrite 10 and 3 with a same base? No, right? So there is no way we could make a same base on both sides. Now, if this is the case, so if you cannot rewrite your exponential equation with the same base, then we have to take, okay? So we have to take log on both sides, okay, with suitable base. Now here, so our base is 10. So let's take a common log on both sides. It means you apply common log on both sides. So here we could not make a same base on both sides, and because of that we applied common log. So we take a common log, or you can just take a natural log, it does not matter, okay? We always get the same value, but in general we use a common log or a natural log, okay? So we just we added log in front of these two expressions. That's what we did.
So is the x on this log 3x, would that be a 1?
No. So log of 3 to the power x is not 1. So to be 1, I think, so for example, if we have log of 10, then this is equals to 1, because this log has a base 10. So in general, if we have log of a to a base a, then this is equals to 1. So in our case, we have log of 3 to the power x. Now, so this is our first step. Now here we have exponents, right? So what can we do to this exponent? We can write this in front of log, right? So let's use the property of log. So we have 2x minus 1. Make sure to have a parenthesis, 2x minus 1, and log of 10 as it is equals to, in the similar way, we have x as an exponent. We can write that in front of log, and we have x times log of 3. Any question up to here? So log of 3, these are just numbers, okay? You can just use your calculator and write down the value of log of 3 in terms of number if you want, but that is not required. Okay. Now what do we know about log of 10? This is 1, right? So our equation looks like 2x minus 1 times 1, which is 2x minus 1 equals to x minus log of 3. Our target is solving for x. We want to know what is the value of x. Now how do we simplify this? So let's collect the terms with x together. So these are the terms with x together. And let's rewrite our negative 1 on the other side. So let's add 1 on both sides and subtract x of log 3 on both sides. We are trying to solve for x. Log of 3 equals to 1. So this is 0, this is 0. We have to make our x by itself. Now what would be our next steps? How can we solve it? So we have x here, we have x here, right? So we can factor out x. So let's factor out x, and we have 2 minus log of 3 as it is equals to 1. Now let's get rid of 2 minus log of 3 by dividing both sides by 2 minus log of 3. 2 minus log of 3. So this and this cancel. So our x is 1 over 2 minus log of 3. And this is the solution. This is the value of x. If you use a calculator, you get a 1 number, okay, for this expression. But it's okay to have your answer in terms of log. So here, if you cannot make a same base on both sides, then you have to take log on both sides. You can take a common log or a log with a base e, natural log, or you can take log to any base, it does not matter. Okay, that's the key step here. So applying log on a both sides is the key step, and the remaining is simplifying using the power rule. You are making your x by itself on one side, and that's what we have here. So our x is by itself, and if you have your x by itself in one side, it means you have the solution. Okay. Okay, any question on this example? Okay, now let's go to the next one. Suppose a bank pays interest at a rate of 5% compounded continuously. Okay, so the bank pays interest of 5% compounded continuously on an initial deposit of $1,000. So we deposit $1,000 on a bank and it pays us 5% compounded continuously. How long does it take? So how long does it take for an investment of $1,000 to grow to a total of $1,200, assuming that no withdrawals or additional deposits are made? Now, at first, we have to collect what is given to us. Now, what is this 5%? What is this $1,000 for us? How do we represent our 5%? That is 5% is a rate, right? So that is a R. So our rate, which is R, is 5%. And if we have a rate, we always rewrite our rate in a decimal. Now, what is 5% equivalent to in decimal? Is a 0.05. Now, it is compounded continuously. Now, if we go back to our section 4.2, and there is a compounded continuously. So, what's the formula given to us? So, is it in 4.2 or 4.3? Is in page number 4. So if we go to page number 4, okay, so this is the formula here, the compounded continuously. So our amount is P times e to the power RT. P times e to the power RT. So the formula for compounded continuously, the amount is P times e to the power RT. Okay, so this is the formula. It will be given to you. Now in this formula, A of T, this is the amount. Okay, P is the principal, E is a number, R is a rate, T is a time. Now what about this $1,000? What is that for us? So we deposited $1,000 to a bank. Now what is that $1,000? Is it amount, principal? It's not rate, we already have, or a time. What do you think? What is $1,000? Is that amount or principal? Principal. Okay, so principal is the sum or amount of money that you deposit or a loan amount. So our principal is $1,000. So P is $1,000. Now the next here, how long does it take? It means what variable we are asked to find here. How long does it take? Are we asked to find amount, P, E, R, or T? So how long means it's a time, right? So we want to know what is time. So we want to know the time here. So time is unknown. So how long does it take for an investment of $1,000 to grow to a total of $1,200? Now what is that $1,200? That's the amount that we want after investing $1,000. So A of T, or simply amount, is $1,200. Now we replace all these values in our formula. Okay, so let's go back to our formula here. So amount is $1,200 equals to principal is $1,000 E is just a number, R, which is 0.05 time is T. That's an equation. Now this is an exponential equation. Okay, our target is finding the value of T. Okay. Now to find that, at first we have to have exponential expression on both sides. So we have 1000 here. Let's get rid of 1000 from right side, and we get that by dividing on both side by 1000, right? So we have 1.2 equals to e to the power 0.05 t. Now can you solve from here? Now it's very similar to our second example. Now this is our exponential equation. What is the base on the left side? 1.2. What is the base on the right side? E. E is 2.8. Now can we rewrite this exponential equation with the same base on both sides? Can you make a same number on both sides here? It's not that easy.
What does E represent?
E is a number, 2.87. Like on your calculator, there is a E. So E is just a number. Okay, it's 2.87 and so on. Okay, E is just a number. Now, since we cannot make a same base, we take a log on both sides. Now, since the base is E, so let's take a natural log on both sides. So let's apply natural log. So ln on both sides. So we take ln, okay, natural log on both sides. Because our base is E here, it will be easy for us to simplify. So we have ln of 1.2 as it is, equals to, now what is this? This is the exponent. Now we can rewrite this exponent in front of log. So we have 0.05 t ln of E. Now what do we know about ln of E? That is equals to 1. Okay, like log of 10 is 1, ln of E is also equals to 1. So you can find the value of ln of 1.2 if you want. If not, you can keep this as it is, equals to 0.05 t. Now we get rid of 0.05 by dividing both sides by 0.05. Now, so we have ln of 1.2 divided by 0.05 equals to t. Now I need your help here. Can you use your calculator and find the value of this here? So make sure you are using natural log. Ln of 1.2 divided by 0.05. And if you need help in entering this correctly on your calculator, let me help you, okay? Yes. So ln, so okay, look for ln. So here, so this is the ln, right? So ln,
Oh, it's LN. not
yes,
LN.
no, that's ln, yeah. Now ln of 1. No, that's ln, okay. 1.2, right? It's close, and divided by 0.05. So 3.6. So our t is two decimal. So this 3.65. Okay. So our t is 3.65. So after 3.65 years, $1,000 becomes $1,200. So here, our exponential equation, it helps us to find the time here. Okay, any question? Now, the next here, we have a log equation, and we have to solve this log equation, okay? Okay. Okay, so here we have a log equation. So we have a log expression in an equation. So this is a log equation, and our target is solving log equation. Okay, now if you have a log equation, then you have to rewrite log expression in one side and the remaining expression on the other side. Okay, so here we have log x. So this is our log expression. This is a constant. This is a constant. So let's write down log expression in one side and the remaining on the other side. So let's get rid of 4. To get rid of 4 from left side, we subtract 4 on both sides. So we have log of x to a base 3 equals to, sorry, we are subtracting 4. 6 minus 4 is 2. So if you have a log equation, then rewrite that log equation with a log expression in one side and the other expression on the other side. Now, the next here, our target is solving x. We want to have our x by itself in one side. Now, this x has a log. Now, we have to get rid of that log. How can we get rid of log? We can always convert. We can always rewrite our log into an exponential form, right? So, in general, for example, if we have y equals to log of x to our base a, then we can rewrite this using our definition in an exponential form. So we have x equals to base is a and to the power y. So we can always rewrite a log expression in terms of exponential expression. So let's do that. So write down the x equals to, then base. Your base is 3 to the power whatever you have on the other side, which is 2. Power is 2. So 3 square, which is 9. So x equals to 9 is the solution for this log equation. So if we have a log expression equals to some constant number, then always rewrite that log equation into an exponential equation. Okay, so write down the x at first, then write down the base, then whatever you have on the other side, we go to the exponent. And 3 square, 9, which is the solution for this log equation. Any question on this equation? Okay, next here we have this equation. And what type of equation is this? This is also a log equation. How many log expression we have? So here we have ln of x, we have ln of x minus 1. We have 2 log expression, and we have this 2 as a constant. So let's collect, okay, every log expression in one side and the constant on the other side. So we have ln of x minus 1 on the right side. So let's get rid of that from right side by subtracting ln of x minus 1 on both sides. We are collecting every log expression in one side. Okay, so here we have ln of x minus, this is 0, ln of x minus 1 equals to 2 as it is. We are collecting every log expression in one side. So we had log expression on both sides. We subtracted ln of x minus 1, and we have ln of x minus 1 on the left side. Now, what kind of expression is this? So on the left side, we have a difference of log. Now, if we have a difference of log, how can we rewrite that? So difference of log is log of quotient. So this can be simplified log of quotient. So this is our numerator and this is our denominator. X minus 1 equals to 2 as it is. Since we have a difference of log, we have a difference of two log expression with the same base. So we have a log of quotient. Our target is solving. We have to make our x by itself. Now the next, we get rid of log. And how do we get rid of log? By rewriting this log expression into exponential expression. So you write down this expression as it is. X by x minus 1 equals to base. So what is the base of our log? So what is the base of this log? If it's ln, then the base is always e. Okay. If you have log, then the base is 10. If you have ln, base is e. And whatever you have on the other side will be the exponent, e square. And e square is a number, okay? If you want to use a number instead of e square, use your calculator, find the e square, and it gives you a number, okay? Or you can keep e square as it is. Okay, I think if we use a number, it's going to be easier for you. So can you find the value of e square? What is e times e? Use your calculator, there is a e, okay? So you multiply that e times 7.38. So let me use 7.4. Okay, so our e square is 7.4. So here we have x over x minus 1 equals to 7.4. Do you know what kind of equation we have now? What kind of equation is this? This is a, yes. So the base of, no, so here we have this log equation, right? And we are rewriting this log equation into an exponential equation. And to rewrite that, you write down this expression first, equals to base. So what is the base of this log? E. So we have e, and whatever you have on the other side will be an exponent. Okay, so that's how we rewrite our log equation into exponential equation. Now here we have a rational equation. So we are solving rational equation. To solve it, we have to get rid of denominator. To get rid of denominator x minus 1, we multiply both sides by x minus 1. So this x minus 1 cancel. We have x equals to, we can distribute to this 7.4 x minus 7.4 times 1, 7.4. Now we subtract, this is a linear equation, we know how to solve this. Subtract 7.4x on both sides. So x minus 7.4, what is that? 1 minus 7.4. Is it negative 6.4x equals to 7.4? Sorry, so this is, yes, 7.4. This negative 7.4 here. Now we divide both sides by negative 6.4. So now this is cancel. Now what is negative 7.4 divided by negative 6.4? We get a positive number. So 7.4 divided by 6.4 is, can you help me? 7.4 divided by 6.4, 1.16. So 1.16 is the solution, is the value of x for this equation. So whenever you have a log expression, you always need to collect the log expression in one side and then rewrite the log equation into an exponential equation, then simplify from there, okay? Okay, any question on this example here?
I got 1.15625.
Of,
Can you just round it up?
yeah, it's fine, yeah. So if you have close to that, yeah, it's good. So it's not exact, it may not be exactly 1.16 because we rounded it to the square as a 7.4. So there might be a slight change. If you have slight difference, it is still considered correct, okay? So this is how we can solve. Now we have the next example here. So let's see. The cumulative box office revenue from the classic children's movie Finding Nemo can be modeled by the log function. So here we have this function, log function, and this log function gives us the revenue from this movie Finding Nemo. Okay, so this is an equation, log equation, and it tells us the amount of revenue from that movie. Now here our x represents the number of weeks since the movie opened. Okay, so our x is the number of weeks since the movie opened. R of x is given in millions of dollars. Okay, so R of x, that's the revenue. So let me write down that equation one more time. We have R of x equals to 78.05 ln x plus 1 plus 114.3. So we know our R of x, this is the revenue. Okay, revenue in millions of dollars. And our x, it represents the number of weeks. Number of weeks since the movie opened. Now, let's find out what is the question here. How many weeks after opening the movie? So how many weeks means which variable we are asked to find here? Is it R of x or is it x? So which variable we are asked to find here? How many weeks after the opening of the movie? Is it x or R of x? It's the x, right? Because our x represents the number of weeks. R of x represents the revenue. So if you were asked to find the revenue, then you will find R of x. Now here, we are asked to find the number of weeks. It means our x is unknown. So this is what we need to find. So let me read that one more time. So how many weeks after the opening of the movie was the cumulative revenue equals to $300 million? Now what is this $300 million? Is it revenue or number of weeks? That's the revenue. So our R of x is 300. So R of x is 300. Now you replace R of x by 300 and you solve the equation. You will get the value of x. Okay, so let's replace our R of x by 300 in that equation. Okay, we are using the same model. So our R of x is 300 equals to 78.05 as it is, ln as it is, x, this is what we need to find, and everything is same. Now we have an equation here, and what type of equation is this? This is a log equation because we have a log expression. So whenever you have a log expression, how do we solve this equation? We make our log expression, or we collect log expression in one side, and the remaining everything goes onto the other side. Okay, so we have to have log expression by itself in one side. So our target is getting rid of 114.3 and 78.05. So how can we get rid of 114.3 from right side? By subtracting 114.3. So you subtract 114.3. So 300 minus 114.3. What is that equals to? 185.7 equals to 78.05 ln of x plus 1. This is 0. Now we need to get rid of 78.05. Now how do we get rid of 78.05 from log expression? Do we divide, multiply, add, subtract? We divide because we have a product here. Okay, so we divide both sides by 78.05. 78.05. Now I need your help. 185.7 divided by 78.05. 2.4 equals to, this is 1, ln of x plus 1. Now we have one log expression and a number in one side. Now we have to get rid of ln. So how do we get rid of this ln? By rewriting this into a exponential equation. And how do we do that? You write down this expression. So you write down the expression along with log at first. So you write down this expression x plus 1 in one side equals to base. Now what is base here? What is the base of ln? E. And whatever number you have on the other side will be the exponent. So e to the power 2.4. So we have x plus 1 equals to e to the power 2.4. Now let's subtract 1 on both sides. So we know our x is e to the power 2.4 minus 1. Now can you help me here? Can you find e to the power 2.4 and subtract 1? How much? You get exactly 10.
So e to the power of 2.4 is 11 approximately.
Oh, okay, so this is almost 11 minus 1, which is 10. So our x is 10. So after the 10 months of opening that movie, the revenue that that movie make is $300 million. So here we can use the log properties or the method of solving log equation to in this log model. Okay, so this is how we can use our log properties and the way of solving log equation. So on your exam, you will be asked to solve log equation or exponential equation.